Okay, let's formulate a diet for pigs that weigh 10 kilograms and balance the diet for crude protein, lysine, calcium, and phosphorus. So remember, lysine is typically the most limiting amino acid in a pig diet. And when we start discussing proteins and amino acids, we'll discuss that concept in a little bit more detail, this concept of the most limiting amino acid. Okay, the ingredients that we have on hand are corn grain, soybean meal, synthetic lysine, ground limestone, and defluorinated phosphate. So corn grain, our source of energy, soybean meal, our protein supplement, synthetic lysine as a source of lysine, ground limestone as a source of calcium, and defluorinated phosphate as a source of calcium and phosphorus. Now we also need to include a vitamin premix at 1% of the diet and a trace mineralized salt premix at 0.6% of the diet. Okay, so this is a pig diet and it has vitamin and mineral requirements that are beyond the vitamins and minerals that are contained in those ingredients that we're using to formulate the diet. So it's typical to use a vitamin and mineral premix mixed into the diet, okay, to provide those vitamins and minerals that the animal needs. Okay, so we're told first thing that we need to include the vitamin premix at a fixed amount, 1%, and the trace mineralized salt at 0.6% of the diet. So what amount of each ingredient will be required to make 1 ton of this diet, and what will a ton of the feed cost? So, first step in the diet formulation is to make a table of the ingredient composition and then to state the requirements of the animal. Okay, so first we have our table with the list of ingredients: corn grain, soybean meal, synthetic lysine, limestone, and defluorinated phosphate. Then their dry matter content, their crude protein content, calcium content, phosphorus content, and lysine content. And be aware that the numbers provided in this table are percentages on an as-fed basis. Okay, we then state the requirements of the animal. It's a growing pig, roughly 10 kilograms in size. Okay, so if we look at the NRC requirements for a growing pig this size, okay, its requirements include 18% crude protein, 0.7% calcium, 0.6% phosphorus, and 0.95% lysine as fed. Okay, so good. Our ingredient composition values are on an as-fed basis, and our requirements are on an as-fed basis, so there's no need to convert between the two later on. Okay, so we've made our ingredient composition table. We've stated the requirements of the animal. Okay, let's now state our fixed ingredients before we move on. The vitamin premix must be included at 1.0% of the diet. The trace mineralized salt must be included at 0.6% of the diet. Calcium, phosphorus, and lysine will be balanced at the end because remember, once we balance our corn and soybean meal, we don't know how much calcium and phosphorus we're going to need at this point. We don't know how much lysine we're going to need at this point to meet the requirements of the animal. We won't know until we've balanced for crude protein. So before we do that, let's just reserve that space in the diet. And like I said, usually no more than 2% I set aside as space in the diet for balancing those micro ingredients at the end. So we're going to set aside 2% space for balancing calcium, phosphorus, and lysine. So that's a total of 3.6% of the space in our diet allotted to the fixed ingredients. So this means that if the fixed ingredients represent 3.6% of the diet, the corn and the soybean meal are then 100 minus 3.6, or 96.4% of the diet. So remember, when we're formulating to meet the crude protein, we need to remember the corn and soybean meal are not 100% of the diet. Okay, they're 96.4% of the diet. So if the total diet crude protein that we need is 18%, and the protein will come from corn and soybean meal, and we know that the corn and soybean meal can only be 96.4% of the diet because the remaining 3.6 is allotted to the fixed ingredients, then the corn and soybean meal will equal 18% crude protein, which is what we want, divided by 0.964, which is the space for corn and soybean meal in the diet, equals 18.7%. Thus, what percent of corn and soybean meal do we need to achieve 18.7% crude protein? So again, this is a step where I see a lot of students stumble. Okay, we want 18% crude protein in the diet. Corn and soybean meal will be used to supply that, but since corn and soybean meal aren't 100% of the diet, they're only 96.4% of the diet, we need to take that into account. So actually we're going to be formulating for a slightly higher crude protein because it's going to be diluted out, because corn and soybean meal will not represent 100% dry matter of that feed. So let's formulate for protein using the Pearson square method. So 18.7% crude protein is what we desire. That goes in the middle of our square, and our ingredients and their crude protein contents on the left. Corn grain is 8.5% crude protein, and soybean meal is 44% crude protein. So let's now subtract our diagonals, the largest number minus the smallest number. So 44 minus 18.7 equals 25.3. 18.7 minus 8.5 equals 10.2. We add those numbers together on the right side of our square, and they equal 35.5. Now, to determine the percent of each ingredient in the diet, we divide the number on the right side of the square by the total on the right side of the square. The percent corn grain is 25.3 divided by 35.5 times 100, which equals 71.27%. The percent soybean meal equals 10.2 divided by 35.5 times 100, which equals 28.73%. So 71.27 plus 28.73 is 100. But remember, the corn and soybean meal are not 100% of the diet. We have fixed ingredients, so we need to take that into account. Okay, so here in this table we have ingredient, corn grain, soybean meal, and percent of the diet. And you can see the way that I calculated this is I multiplied the percentage that I determined from the Pearson square times the amount that corn grain and soybean meal represent in the diet. Okay, so I just determined from the Pearson square that corn grain is 71.27%. But that's not 71.27% out of 100% of the diet. The corn grain and the soybean meal are only 96.4% of the diet. The remaining 3.6 is our fixed ingredients. So 71% of 96% is 68.7. Thus, corn grain will actually be 68.7% of the whole diet. Soybean meal, 28.73% of 96.4% is 27.7%. So soybean meal will be 27.7% of the whole diet. Okay, so the next step, once you've balanced for one ingredient, is to go back and update your table, your ingredient table. So we've got our list of ingredients, and then the next column is their percent of the diet. Okay, and our next step is to balance for lysine. So we've determined that corn grain is going to be 68.7% of the diet, and soybean meal is going to be 27.7% of the diet. We know that corn grain is 0.25% lysine, and soybean meal is 2.5% lysine. Okay, so for the corn grain, at 68.7% of the diet, multiplied times 0.25% lysine, this means that there's 0.172% lysine in the diet that's coming from corn grain. For the soybean meal, we do the same thing. We multiply 27.7 times 2.5% lysine in the soybean meal, which equals 0.693% lysine coming from the soybean meal. And you can remember, looking at these numbers, what we talked about earlier in the semester with the corn grain being slightly or relatively deficient in lysine compared to the soybean meal. Okay, so if our requirement for the lysine is 0.95%, and we add together the 0.693% lysine coming from soybean meal and the 0.172% lysine coming from the corn grain, that tells us that we still need 0.085% lysine in the diet in order to meet the requirement for these 10 kilogram growing pigs. Okay, so now we have a simple calculation in order to determine how much lysine to add to the diet. This is synthetic lysine, so it's 100% lysine. So 100% lysine times 0.085 equals 0.085. So we need 0.085 lysine in the diet, 0.085%, in order to achieve 0.085% lysine in the diet. Does that make sense to everyone? We're simply multiplying the amount of lysine in the diet times the composition of lysine in the synthetic lysine, which is simply 100%, which gives us how much lysine is in the diet from that ingredient. Okay, and we've now met our requirement for lysine. Okay, so finally now let's balance for calcium and phosphorus. Again, we update our ingredient table. So we have for the corn grain and soybean meal the percent of diet, and then for calcium and phosphorus, how much calcium and phosphorus is in the corn grain and soybean meal, and then how much of the calcium and phosphorus is in the diet. So for the corn grain, for example, it's 68.7% of the diet and contains 0.03% calcium, so 68.7% times 0.03% calcium equals 0.021% calcium in the diet from the corn grain. And we do the same thing for the soybean meal. Okay, phosphorus, similarly, corn grain is 68.7% of the diet. Corn grain contains 0.23% phosphorus, and we multiply the 68.7% times the 0.23, and that gives us 0.158% phosphorus in the diet coming from the corn grain. Okay, and remember, phosphorus relatively high in the seeds, calcium higher in the leaf and stem portion of the plant. So you can see that illustrated by the corn grain. It has a much higher percent phosphorus than percent calcium. Okay, so then we add up our amounts, and what you can see at the bottom of the table, I've indicated the requirement. So phosphorus is required at 0.6% of the diet, and calcium is required at 0.7% of the diet. So if we look first at our phosphorus, we have 0.262% phosphorus, okay, that we need to add into the diet, or that we're short of the requirement. Okay, so defluorinated phosphate is the ingredient that we have at hand that will provide phosphorus. So bear in mind that the defluorinated phosphate also provides calcium. So we're also partially balancing or possibly completely balancing for calcium when we add in the defluorinated phosphate. So you can see here in the table the defluorinated phosphate contains 32% calcium and 18% phosphorus. So now to figure out how much to add to meet the phosphorus requirement, we have 0.18, so the amount of phosphorus, times X, the amount of defluorinated phosphate, equals 0.262, the amount of phosphorus that we still need in the diet in order to meet the requirement of 0.60. So X then equals 0.262 divided by 0.18, which equals 1.46. So now we plug 1.46 into the table. So defluorinated phosphate will be in the diet at 1.46% of the diet. So now we can fill out a few more entries in the table. So if the defluorinated phosphate is 32% calcium and it's present at 1.46% of the diet, we multiply those two numbers, the defluorinated phosphate will actually add 0.467% calcium into the diet. And at 1.46% of the diet, the defluorinated phosphate multiplied times the percent phosphorus, 18%, will provide 0.262% phosphorus to the diet to meet our phosphorus requirement in the diet. Okay, does that make sense to everyone? So now that our phosphorus is balanced, the last step is to balance for our calcium. So when we added the defluorinated phosphate into the diet, this gave us another 0.467% calcium into the diet. So that 0.467 plus the calcium that's coming from the soybean meal and the corn grain now leaves us only 0.129% short of meeting the requirement for calcium for these growing pigs. So we're going to use limestone to balance for the calcium. Okay, so then our equation is 0.358, so the limestone is 35.8% calcium, so 0.358 times X, the amount of limestone, equals 0.129, the amount of calcium that we need in the diet. So X then equals 0.129 divided by 0.358, which equals 0.36. Limestone will thus be 0.36% of the diet. Okay, so now let's add up all of our components of the diet and see where we're at. We've balanced for crude protein using the corn grain and soybean meal. We've balanced for our lysine, and we just finished balancing for our calcium and phosphorus. Okay, so this table shows the diet composition. So we have a list of ingredients and then their percent of the diet. Okay? When we add those up, we have 99.905%. Okay, that's not really going to work too well, because when we send this recipe to the feed mill and they ask us to mix these components, or when we ask them to mix these components, we want that total to be 100%. Okay, all of these ingredients should be out of 100 in order to make a total diet. Okay, so the easiest way to accomplish this, the rule of thumb, okay, is to figure out how much you're short. So we want 100, we've got 99.905, we're only short 0.095. So what I always do is just add that little extra percentage back to corn grain. Okay, it's not going to affect the composition of the diet that much. So if we add that back, we've got a little bit more corn grain in the diet, and now we've got a total of 100%. Okay, so now we have our table that has a list of ingredients, their percentage of the diet, and then over on the right side, how much of that ingredient on a per ton basis, because remember our original problem. Okay, so there's 2,000 pounds in a ton. Okay, so if corn grain is 68.795% of the diet, 68.79% of 2,000 pounds, or 1 ton, is 1,375.9 pounds. So if we do that calculation for every other ingredient, okay, we have the amount of each ingredient on a ton basis. Okay, so we're mixing these ingredients at the feed mill to make a ton of diet. So that's exactly how much of each ingredient we need to weigh out in order to make a ton of this diet. Okay, so now let's figure out how much it's going to cost us to make this diet. So we'll add another column to our table. We have the list of ingredients, their percent of the diet, the amount of each ingredient in pounds per ton of diet. Okay, and now we have another column here where we have the cost of each ingredient per 100 pounds. So corn grain is $8.50 per 100 pounds. Okay, every 100 pounds of soybean meal is $25. Okay, so now we add another column onto the table. Okay, so we know that corn grain is 1,375.9 pounds per ton. And we know that the corn grain is $8.50 per 100 pounds. Okay, so we can divide the pounds per ton value by 100. So remember, our cost is on a per 100 pound basis, and multiply that by the cost per 100 pound. So for example, we have corn grain at 1,375.9 pounds per ton of diet, and it's $8.50 per pound. So 1,375.9 divided by 100 is 13.759. So then we multiply that times $8.50, because that's how many hundreds of pounds that we have, and that tells us that the corn grain is going to cost us $116.95 per ton of diet. Okay, we do the same thing for the soybean meal, 5.54 times $25, and the same thing for the other ingredients. And what you can see looking at those ingredients is that, especially for those minerals, that it's relatively inexpensive to balance for calcium and phosphorus. And these sources of minerals that we use are relatively cheap, relatively inexpensive to include in the diet. So now if we add up all of those costs, this basically tells us that for every ton of diet that we have made, it's going to cost us $265.01. Any questions?